Hi and welcome. My name is Bo Ekberg. I'm a circuit breaker application specialist of a Megger factory in Sweden. Today we're going to do a DRM, a dynamic resistance measurement, and a contact resistance measurement on our outdoor breaker outside the factory. During the measurement we're going to use TM1700, SDRM202, and since we are in the demo environment we also need the power supply for the coils, a B10E. The method DRM, you measure on the main contacts of a circuit breaker between the two contact points. You detect the inside of a breaker to analyze the details, mainly the arcing contact length. You measure voltage, current to calculate the resistance, and you also measure the motion. By that you can see details of the arcing contact. The DRM, the dynamic resistance measurement, is mainly measured on SF6 circuit breakers. The contact resistance measurement, SRM, is measured on all kinds of high voltage circuit breakers. The Megger was the first company to introduce products for the DRM method in the early 90s under the name Programma Electric. Let's go outside and do the measurement. Here I establish by the circuit breaker. As you can see, this object is in a demo environment at our training site. The breaker has been adapted with stockings as protection. And the breaker is not connected to the network. At a real station you of course need to do all safety procedures with disconnecting and grounding and follow all the local safety instructions. I connect the supply to the coils to B10E, and I connect the supply for the motor, for the charging motor of the mechanism, to B10E. I need to link the trigger and I have prepared in advance the power supply and the grounding. I can start the connection as the instrument. I connect the plus link and the minus link between the channels. I connect the plus from a supply, in this case B10E, and the minus from B10E. I connect to the connections that goes to the control cubicle. I connect the close command, yellow, and the green, the open command. And I also need to meet with a minus on the coils. I connect the connections in the control cubicle, the close, the yellow, and open, green, and I meet with the minus, the black cable. I also need to connect the motor supply, the red plus, and the black to minus. I need to do the connections for the resistance. I use the MR cable for voltage change. I also connect at the pole. I do the connections for the motion, and I'm using the digital transducer, so I'm connecting to the digital module, the first channel. Here I connect the motion transducer at the circuit breaker mechanism. Make sure it's not in the way for the moving parts of a circuit breaker. The adapter is mounted in an existing drilled hole in rotating point of the mechanism. Connect flex coupler to adapter. The mounting is very important for the final result. Make sure you mount the parts with space between each component. The flex coupler must not be stretched or pressed, but needs to move freely to cover any misalignment. The whole setup must be mounted in a straight, strong and steady position. Attach the base, arm and white holder together. Attach it to the structure of the circuit breaker. Mount angel transducer in the white holder and connect the cable. I connect the grounding at the SDRM box. And the multi-cable. I mount the box at the pole and I start to connect the current cables. The black cable at the top to the lower part of the circuit breaker, and I connect it outside the voltage sense. The red cable at the lower part of the box, which is the long cable, and I attach that one at the top of the breaker. And again, the current cable needs to be outside the voltage sense. I need to connect the SDRM box. I start with connecting the supply to the box, and I connect the red and black trig cable to the trig of the instrument. I continue with the current channel, channel 1, to the first analog channel of instrument. Here I have my circuit breaker, and as you can see, I don't have my resistance recordings in the menu. So I need to add SRM and DRM in my setup. I go to the test plan editor and I start changing my setup. I need to add the SRM to my menu, and I want to split it phase by phase. By that, I will now have menus for each phase, A, B, and C. And I want to add the DRM, dynamic resistance measurement. By that, I select Open, and I deselect the timing and select the DRM. I also checked contact motion. That's I split phase by phase, trip coil current, and I remove the auxiliary contacts. I need to change the name to have a unique name, Open DRM. And here I get my three operations, SRMs and the DRMs, one for each phase of both static and dynamic resistance measurement. By that, I finish and close my test plan editor. Here I have my circuit breaker set up, and I start with creating a new test. I start with the SRM, and I start a new recording. And I need to select the current transducer. And I'm using channel 1, so I need to select transducer for that. And now I'm ready to start the measurement. The static resistance value occurs on the screen. I can read out the value 25.8 microohms. I can close the window and continue to do 2 to 3 more measurements to see that the result is constant. I've done my static resistance measurement, and now I want to continue with my dynamic resistance measurement. I select the DRM, and I double-click on the motion channel. And I use relatives. I don't have to select a transducer, but still I need to double-click. After that, I'm prepared to turn the knob and do the measurement. I get the result on the PC screen. The first thing I have to do is change the graph's layout. I go to Layout, and I change Layout Settings. I remove the voltage. I make sure motion, current and resistance is turned on. I change the Y scale. I want 20 for the motion. I want 20 for the current. And I want to change resistance to 200. I want the X scale to be 2 milliseconds per division. And let us see. I need to center the graph a little bit, so I move the whole graph. So I can see the current at the top, red, motion red, and the resistance in a dark color. Now I need to put the cursors in the right positions. I put the first cursor where the breaker opens. And that is where the current drops at around 24 milliseconds. I needed to move it exactly to the dropping point there. And I go to the second cursor and I put it to the big resistance step. So I move it to, let's see, this slope. And now I can read out the difference in millimeters from the two cursors. 12.83 millimeter. This is not an exact value because I'm using relative, but I can have it as a reference for future comparisons. Again, I do 2 to 3 recordings more on each phase. There are other ways to use the SDRM202. You can measure the breaker with one side grounded, or you can measure with the circuit breaker 2 sides grounded. And the box has 2 channels, so you can measure 2 breaks per phase. Here is an example where we have connected one box on each phase on all 3 phases. The breaker has 2 breakpoints, and we measure this 3-phase breaker all breakpoints at the same time, 6 breakpoints in total. Or as we show here, where the SDRM202 and the dual ground timing, DCM, is connected at the same time on the circuit breaker. All the connections at the circuit breaker can be done from start. You don't have the DCM timing leads connected at instrument during the DRM measurement, but they can be connected at the pole of the breaker. After checking the result, it's time to do backup of the results of the data from the PC to a USB memory. Clean up all the cables and put the circuit breaker back into service again. Thank you for the attention and good luck with your measurements.